Question 1. Work out 1.7 cubed. Well, that's 1.7 times 1.7 times 1.7. And on your calculator, and if you hear my buttons going in the background, that's me using my calculator. So 1.7, and I'm going to use to the power of 3, I'm going to use that power button, and I would get 4.913. So that's 1 mark. Question 2. It says there are only red sweets and yellow sweets in a bag. And it says 2/5 of the sweets are red and there's only red and yellow, so that would mean that 3/5 of the sweets are yellow. And it's asking you to write down the ratio of red sweets to yellow sweets. Well, if you think about it in these simple terms, if it's in terms of fifths, then red has 2 of these fifths while yellow has 3. So that is actually your answer, 2 to 3. So another way of thinking about it, if you don't like that, is to start off with these fractions here. You could almost say it's the ratio of 2/5 to 3/5, and you might think that was right, but what they're looking for here is a whole number in terms of the ratio. So you could times this side by 5 as long as you do in proportion the same to the right hand side, and times that by 5, and that would give you 2 to 3, which is the answer. Question 3. Draw a chord of this circle. Well, a chord is a straight line going from one point on the circumference to another. So I could say that's a chord. I could start from here and go, say, to here and say there's another one. Not quite where I wanted to go, but that's still a chord. I could even go right through the centre if I wanted to. So say my centre was here and I went right through it to the other side. Now you might think that's a diameter, which it is, but it's also a chord. So any straight line going from one point on the circumference to another will be a chord. Question 4. On the grid, complete the diagram of a parallelogram. Now, a parallelogram, and the way I remember it is that a parallelogram has 2 L's that, for me, are parallel. Okay, so it's got opposite pairs of parallel sides. So what we must look at in this diagram, and this is a good way of doing it, is to say, okay, I want something parallel to this line here. Now, if I look at how I can move from this point to this point, I can go 3 along and 1 up. So if I start from here and go 3 along and 1 up and draw a line here, so I'll try and draw this properly. There we go, not brilliant, but it will do. That will be parallel to the line which I started with. And then you could say, okay, I also want one that's going to be parallel to here. So can you think what you've got to do? Well, if you start from a point, say here, and go back 2, then up 3, then if you start from here, you'd have to go back 2 and up 3, and you'd get to the end again. Now, obviously, some of you are shouting at the computer saying, what an idiot, why don't you just start from here and end up here? Well, that's fine, but that's only if you've done this side here. Maybe if you wanted to do this one first, that's what you'd have to do. Go back 2 and then up 3. So I'll join that up now, and that should be our finished parallelogram. A bowl contains 1 apple, 1 banana, 1 orange, and 1 peach. 2 pieces of fruit from the bowl are taken at each time, and you've got to write down all the possible combinations. Well, we'll start with apple here, and we'll try and start with apple as many times as we can. And it wants combinations, so I'll explain that briefly to you. So apple and then banana. And you might think, well, what about banana then apple? Well, a combination just means that apple and banana have been chosen in any order. The order's not important. So apple, banana will do for now, and then we can start with apple and then go on to orange, and then we can do apple and then peach. So we can kind of cross apple off our list as our beginning piece of fruit, and then we can go to banana, and then on to orange. Don't forget, we wouldn't write then orange then banana, because that's been counted already. So banana, orange will do for both of those. And then we can go banana and then peach. And can you see what the last one is that's left? So if I section these off, it goes 3 of these, 2 of these, so you'd expect 1 of the last one, and indeed it's orange and then peach. So there's always a nice pattern to these. Okay, so we've got a 3, 2, 1 situation going on there. So if you try these other questions again, you'll see a pattern. Question 6. The first term of a sequence of numbers is 18, and the term-to-term rule for this sequence is add 6. So it would go 18, then add 6 is 24, then 30, 36, 42, and we'll be there all day. We can carry on and on. But it's asking, is 603 a term of the sequence? Well, if you look at 603, you should note that it is odd, whereas all of these are even, and will continue to be even, because if you start with an even number and add an even number, you're going to end up on an even number. And that would be part of your explanation, which I'm not going to write for you. Just think about it in your own words, as long as you get those points across. Well, apparently someone is saying that no terms of this sequence are multiples of 7. Well, multiples of 7 are the 7 times table. So 7, 14, 21, 28, 35, 42, 49, and so on. And you're allowed to use a calculator here. So if you just started with 7 and just did add 7, add 7, add 7 each time, you could get your times tables done pretty quickly. Now you want to see whether there is an example to show that RISV is wrong. Well, if you compare here, you can see that 42 sticks out a mile. So 42 would be your example that you would use to show that RISV is indeed wrong. Question 7. It gives you a regular hexagon and it says there's shape A and shape B, and you've got to work out which shape has the greater perimeter. So let's just say that each length is 1 unit, and if you want to use algebra you can call each part of the length n. It's up to you, or another letter. We'll just call it 1 unit for now. And I'll start here in this shape here, and for this one I'll start here. So for this one I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 units. So that'll be for shape A. And then if I start here and go clockwise again, I'll get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units. Now, they're regular, so 1 unit's the same as the other, so each length's the same. So, which shape has the greater perimeter? Well, A has the greater perimeter. Now, visually, you can see that shape A denies 2 lengths to be part of the perimeter, whereas shape B denies 3 lengths to be part of that perimeter. So This is more compact. Question 8. A road map has a scale of 1 to 50,000. The length of the road on the map is 8.5 centimetres. We have to work out the length of the real road in kilometres or kilometres. So on the map, if we had 8.5 centimetres, well, the first thing to do is use our calculator and do 8.5 times 50,000. And on my calculator, I get 425,000 centimetres. Now, that's in centimetres. We've got to change to kilometres, so that's quite tricky. So if we remember that 100 centimetres is just 1 metre, and 1,000 of those metres is 1 kilometre, we should be okay. So let's convert this to metres first. So for every 100 will give us 1 metre. So if we divide that 425,000 by 100, we will get 4,250 metres. So if every 1,000 of those metres gave us only 1 kilometre, then surely we'd just have to divide 4,250 by 1,000. So you can either see that's 4.25, or you can just do it on the calculator and you get 4.25. So 4.25 kilometres is the answer. Tom says that ABC, the straight line ABC, cannot be a straight line. Okay, so he's saying that ABC cannot be a straight line. So let's not assume that it is. It looks that way, but he's saying it cannot be the case. Well, there's only one way of checking that out with the information we've got, and that is to use facts that angles on a straight line sum to 180 degrees. Because if you look at a circle and you started from the centre and you went all the way around, then you would be turning a whole turn, which is 360. So if you went half the way around, you would be turning from here, this was your turn, you'd be going all the way around 180 degrees. So 180 degrees is on a straight line. Let's see what 146 and 32, let's get that right, 146 and 32 add up to, well, you can use your calculator, 178 degrees. So if you write 146 plus 32 is 178 degrees, 178 degrees would not, I'll get my writing a bit better actually, it's pretty scruffy. 178 degrees would not be enough. And then I would end up with saying, so Tom is correct. Question 10. Uzma is planning a party for 120 children. She's going to give every child a toy. And it says here that a pack of 8 toys costs £4.35. Right, so we've got to be careful here. So they come in packs of 8, so we've got to work out how many packs we're going to have first. So if we take the 120 children and divide it by 8, that would tell us how many packs we want. So you can use your calculator. I'll do a little non-calculator method as well. So you can just halve numerator and denominator each time, and 30 divided by 2 would give what your calculator would be saying, which is 15 packs. Now, each of those packs of 8 toys costs £4.35, so we'd have to do 4 I was about to do that by long multiplication, which I'm not going to need to necessarily do. I'll use my calculator here. I might just finish it off if I've got a bit of time. So let's have a look. So we're going to do 4.35 times 15, which gives me £65.25. I'll just finish this quickly, it won't take long. So that's 22, 23, 25 and 6. So yes, the same, £65.25p. Question 11. Daisy thinks of a whole number. She multiplies the number by 3 and Daisy's answer is 34. We have to explain how we know that Daisy's answer is wrong. Well, if we multiply a number by 3, then it will be in the 3 times table. And if we write the 3 times table out, it's worth doing this bit so you can see what's going on, then you can see that by the time we've gone past 34, we're at 36. Well, we can't see 34 anywhere, can we? And the reason is because 34 is not a multiple of 3. So I would say 34 is not a multiple of 3. For this part of the question, there's a number machine, and Abby says that when the output is 36, the input is 60. Well, let's have a look what should happen by looking at the number machine as it stands. Well, if we put 60 in, and then we added 6, like it asks us to do, and then times the answer by 2, well, we'd have 60 plus 6 is 66, and then 66 multiplied by 2 would be 132, which certainly isn't 36. So something has gone wrong, and what she's done is she's multiplied by 2 when she should have divided, and she did the reverse operations in the wrong order. So to get back from 36 to 60, she should have done divide by 2 and then minus 6, whereas what she's actually done is done minus 6, which is good in some ways, but she's definitely missed out the divide by 2. She's in fact done times 2 instead. So if we wanted to see what the true answer would be, then if the output was indeed 36, let's just say that is correct, then if we went back through the number machine, we'd have to divide by 2 at this point, which would give us 18, and then take away 6, which would give us 12. And if we went forward from here, we'd go 12 plus 6 is 18, times 2 would indeed end us up on 36. So I'll put the writing in there afterwards and then you can see for yourself. So she has multiplied by 2 when she should have divided by 2, and she did the reverse operations in the wrong order. Question 12. Work out the value of the square root of 2.7, add 6.5, all divided by 4.8 minus 1.06. Now, why have I put brackets around there? Well, when you come to use the calculator, what you can't do is get the order of operations wrong in terms of identifying clearly to the calculator what needs to be done and in which order. So, as we have a fraction, and the division sign shows us how a fraction works, that division sign means we have a number on the top and a number on the bottom. So the number on the top I think we should sort out first. So the brackets would be there if you wanted to put the whole thing in at once, and I can do that at the very end, but I think at this stage we should probably do the top first and then the bottom. So let's sort out 2.7, the square root of that. So I would do use my square root button. So let's turn my calculator on first. So we'd have square root 2.7, And I personally would write that as a decimal, so I'm going to write 1.643167673. That's not exact, but it's good enough. It's on my calculator display, plus the 6.5. And then separately, I'm going to do the denominator. So I'm going to do 4.8 minus 1.06, and that gives me 3.74. Now I'm going to just clear up this part here. So I'm going to have 1.643167673 plus 6.5, which is 8.143167673, and then I'm going to divide that at the very end by 3.74. Now I'm going to put all the numbers on my calculator down, and then I'm going to round to 2 decimal places. So that's going to give me 2.18 to 2 decimal places. Now, what would be the quick way of doing it? Well, I'll try this on my calculator as well, and I'll try and do this at the same time. So bracket square root 2.7 plus 6.5 close bracket divide by open bracket 4.8 minus 1.06 close bracket, and I get 2.177317,559. Now you might think, oh dear, that's wrong. Well, 559, all it means is the calculator's just rounded, or truncated is another word, so you can say truncate or round. It's just rounded this here for the calculator display, and therefore this 9 has made this a 6. But to 2 decimal places, it made absolutely no difference, did it? So 2.18, 2 decimal places, is absolutely fine. Question 13. Drinks and snacks can be bought in a cinema, and basically Laura is going to buy 1 drink and 2 different snacks, and we've got to work out the most money that she can save using the special offer, which is buy 1 drink and 2 different snacks for $3.99. So I guess to save the most money, she would be going for the most expensive of each kind and then adding that up. So let's go with the £1.50, and you've got your calculator, don't forget. The popcorn, which is 1.75 or £1.75 rather, and not the nachos. I like the way they've put that in that order to try and catch you out. So, and then £1.60, and we'll add that up, and then we'll get 5 and 11, that's 18, and 1, 2, 3, so that's £4.85, and you can top that up on your calculator, that'll be the same. And buy 1 drink, it says $3.99 is the deal. So if we had $3.99 as the deal, then you surely shouldn't need a calculator to work out that it's 86p would be the maximum saving. That's assuming that she wants to go for the most expensive and get the most out of the deal. Question 14. It says 3/8 of the people at a football match are men, and 27% of the people at the match are women, and the rest children. We've got to work out what percentage of the people at the match are children. Okay, so there's our 3 different categories. So luckily, women, we already know, is 27%. Now, men, we definitely can do something with our calculator here. If you do 3 divided by 8 and decimalize it, you will get 0.375. Now, if you think to probability, which is a good way of looking at it, 0 impossible, 1 certain, think of the decimal scale, then 0.5 would be halfway. Okay, so that would be 1 over 2, or a half. Then, if you thought there was a certainty of something happening, you would say 100%. And impossible, 0%. So if you think about where 0.375 would be, well, that would represent 37.5%. Okay, so one good way of thinking about a decimal is imagine a probability line. That helps me. And then if you look at children here, well, surely you can think about adding those two up and seeing what's left to make up 100. So if we do 37.5 plus 27, we will get 64.5. So the sum would be 64.5, and then you would know that what was left would be 100 minus 64.5 would be what's left. So I'll do 100 take away 64.5, and we get 35.5%. And then I think if I had time, I would probably just add these three things up and hope that they make 100, and then I would definitely move on to the next question. Or even if you finish the paper, when you're checking, it's best to check. In fact, it's vital to check these kind of details, because it's sometimes these really easy questions that can help you lose marks. Question 15. Jake is going to make a path from small paving stones and large ones, and we've got a diagram to show us the configuration, and we've also got the costs of each. And Jake needs to buy enough paving stones to make a path that is 6 metres long. So the first thing we need to look at is 6 divided by 1.5, and you can use your calculator, of course. And I would get 4. Now, what that means is that we must multiply how many small tiles we have by 4 to make one that's long enough, because he's going to have 4 of these designs, don't forget, altogether, making 6 metres worth. So if we just calculate those, just label that as small, and then we'll have large here. So the small ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but we've got to times that by 4, that will give 40 in total. And the larger ones, 1, 2, 3, so that's going to be 3 times 4, and that's going to be 12. Now we can use our calculator, and the small ones are £2.30, so we're going to have 40 times 2.3, and that's going to give us £92, and then we're going to do 12 lots of 3.65, and that's going to give us £43.80. What I should probably have here would be, because I've got 12 times 3.65, and here I've got 40 times 2.30. I guess you really should show as much working as possible. And then we want our total, and then we're just going to add those up. Again, use your calculator at leisure. And then we've got 0, 8, 5. So we've got total cost there is £135.80p. Now Harry designs a different path that is also 6 metres long, using the large ones only. So again, we're going to have 4 lots of the design shown. And how many large tiles are we going to use? Well, we're going to look at this and say 1, 2, 3, 4, 5, 6. So we're going to have 6 lots of 4, and that's going to be 24 in total. And the larger tiles were £3.65. So the total cost will be 24 times 3.65, which is going to be £87.60. And Harry says that the cost of this path, will be less than half of the cost of the path that Jake designed. Well, Jake's was £135.80. So if we divide that by 2, we'll get £67.90 for half, and we've got to compare that to £87.60. Well, what we can say here is £87.60 is greater than £67.90, so we can say it's not true. So in September, Sharon paid £565 for some books. She sold all the books for a total of £780. So let's have a look at the difference between those two figures there. And we're going to get £215 as a difference there. We can say that's profit. In October, so this is September, so in October Sharon bought and sold some more books, and the total profit she made in October was 13% greater than the total profit she made in September. In November, Sharon wants to pay a bill of £30. Sharon thinks that the 13% extra profit she made in October will be enough to pay this bill. Is Sharon correct? Well, let's work out 13% of, well, the profit she made in September, so 215. So on the calculator, that's 13 divided by 100 times 215, or just straight away 0.13, using your idea of converting percentage into a decimal straight away. And let's see what we get. Well, I get £27.95. So I'm afraid you can say this 13% of September's profit is not enough to pay November's bill of £30. Okay, so that's reasonably straightforward. Question 17. Solve 5 equals 100 divided by x. Well, if we multiply both sides by x, that will give us 5x equals 100. And then if I divide both sides by 5, that will give me x equals 20. If you're not sure on how to do these types of equation, there are plenty of videos that I've done on equations, starting from easier ones to difficult ones. Also under the topic of rearranging equations also, you'll find some useful techniques there. If this kind of problem is difficult for you, then you must do a bit of research now. You can't just forget about it, you've got to meet it head on, so I suggest you do some research on how these methods work. Question 18. We've got to write an integer in the box to make the statement true. Well, an integer in this case being a whole number. Now, integers can be positive or negative, but I think the first thing to look at is 2/7 the same as something with a numerator of 6? Well, if we multiply the top by 3, we'd have to do the same to the bottom to keep the value the same. And that would mean the bottom part would be 21. So 2/7 is in fact the same value as 6/21. Okay, so that's the first situation. And if we write 21 in here, then that wouldn't be the case of being greater, it would be equal to. Okay, so we want something where 2/7 is greater than 6/21. So really this number that I put in here would have to mean that this fraction would have to be less than what it is now. And the only way of making that less, And the way I think about it is cakes and people. Say for example you had 6 cakes and 21 people. They'd all get some cake. We're not worried about how much that is. But if I kept the number of cakes the same at 6, but I made more people share that cake, say 22, then they'd get less than the situation here. Because if there were 6 cakes between 21, but an extra person turned up and now it was 6 cakes between 22, they'd get less. Which would mean that if the number is more than 21, so if we just call that n, so if n is greater than 21, then, well, we've got plenty of choice now. We've got 22, 23, and so on, up to as big a number as you can possibly think of. I could always add 1 to that, by the way, but whatever you want to choose. Question 19. A television has a normal price of £675. In a sale, the price is reduced by 32%, and we've got to work out the price of the television in the sale. So we can either work out 32% of 675, do that on the calculator. So we can just do 0.32, or 32 divided by 100 times 675. And what do we get? 216. And then do 675 minus 216. I'll use my calculator. And I'd get £459. That's one way. However, in a sale, if the price is reduced by 32%, 675 would represent 100% of its value, i.e. before any reduction at all. So if we reduce that 100% by 32%, there'd only be 68% left, wouldn't there? So if we found 68% of 675, that should give us this value straight away. Well, let's try and see. So let's do 0.68 times 675. And yes, we get £459. So I suggest that you look into percentages, look at some other exam papers that I've done or other people, and just get really used to seeing quick ways of doing these questions. As long as you show you're working, you're going to get all the marks. Now here's a tricky question. I think this is one of these questions where you can just stare at the shape and your eyes begin to go round in circles if you look at it too much. Okay, you really got to concentrate and think, right, what is it saying? It's saying the area of the shaded region is 25% or a quarter of the area of each square. So we know we're going to have 3/4 of that square left because a quarter of that one has been shaded. And we know we've got 3/4 of that one shaded, unshaded rather, because a quarter of it has been shaded. So if the grey section represents a quarter of either square, then let's count how many quarters we've got altogether. Well, I see there we've got 7 quarters altogether. But how many of those quarters are shaded? Well, 1 of those quarters out of 7 of those quarters. So if you think about 1/4 out of 7 quarters, well then it's just one of those quarters out of 7 of them. So the fraction would be 1/7. And if you don't like that, just think about this on your calculator if you want. If you did 1/4 on your calculator, you'd get 0.25. And if you did 7 quarters on your calculator, you'd get 1.75. And if you did that on your calculator, 0.25 divided by 1.75. Well, my calculator converts straight away into a fraction, so if you're lucky enough to have one of those calculators, you're really good. If it just said a recurring decimal like this, so let me just work this out, 142,857 recurring, then you're not giving it as a fraction and you may not recognise what that is. So one other way, if you were really stuck, would be to times top by 100, which you can do on your calculator if you're not sure, the same to the bottom part as well, and then cancel it down. So you know that 25, well hopefully you know that 25 goes into 175, and that will be 7 times, and you know that 25 goes into the top number obviously once, and we can cancel those down and we'd get 1/7. So I think that's a tricky question. Well, I find it hard anyway. Question 21. There are 240 students in Year 7 at a school, and that's shown here in a pie chart. It says some information about comparing this to Year 8, and Andy's going to draw a pie chart based on boys and girls in Year 8. So I think we should first look at how many boys and girls there actually are in Year 7 and in what proportion. So to work out the number of girls, then we're going to do 177 out of 360, because this was 177 and the whole term would be 360. And we're going to times that by 240, and that's what fraction of 240, the total. Now let's have a look what that is. So 177 divided by 360 times 240 gives us 118 girls. And I'm going to write that in there. So of course if we take that away from 240, then 240 take away 118, that gives us 122 boys. So you have to show your workings here, and you can use the calculator of course, so that'd be 122. Now once we've got that, we can then look at the information that Andy needs to draw his pie chart. So if we look at Year 8, boys and girls, it says there are 8 more girls in Year 8 than there are in Year 7, so the amount of girls is going to be 126. And then in terms of boys, it says there are 32 fewer boys. So that's going to give 90 in total. So now let's be careful. Work out the angle of the sector in Andy's pie chart that represents girls. So in Year 7 we had a total of 240, but in Year 8 we've got a total of, and again use your calculator if you need to, 126 plus 90 is 216. So we want to work out the angle of the sector. We know that we've got to do some fraction, and in terms of girls it will be 126 out of the total, which is 216, and that's the fraction of 360 that we're going to need, because that's the fraction of the whole term. So 126 divided by 216 times by the whole way round the circle would give us 210 degrees for girls. Okay, so that's question 22. Here is a number line, and on this number line we have to show the inequality as given. Now if I write this out here and start by reading from left to right, okay, so I'm just getting to the middle part, which is the x. That would read -2 is less than or equal to x. So that would mean that x is greater or the same, greater or more than -2. Now if we looked at x is greater than or equal to -2, then on the number line we usually represent that with, you can write a circle on the line, or you can do it directly above, And a hollow circle would mean that it couldn't be that value, but anything more or less than it. In this case, we want more than or equal to. And because we've got equality here, we just shade it in. Okay, so it's a full circle. And then we can just put a number line arrow going all the way up to as far as we want. So we'll carry that on and on forever. Now let's start from the middle of the inequality and carry on from left to right. And what would we get? We would just get x is less than 3. So in another colour, we can say, right, okay, we've got, and I'll just move this down a little bit, we've got a circle above 3. Can it be 3? No. So it's a hollow circle, and it can be anything less than it. So we can carry that off to, towards negative infinity. Now, what we've got to now look at is where there's an overlap. And there only seems to be an overlap within this region here. Now we've got to look very carefully, because here we could be negative 2, but up to here we couldn't be 3. So on my finished number line that I would actually do with a bit more practice is I'd have a full circle here all the way up to 3, which would be hollow. And that would be my answer for showing it on a number line. Part B of the question is, it says solve 5n plus 3 is greater than 27. Well, let's take away 3 from both sides, which will not change the inequality sign. So we would have 5n is greater than 24. And then we can divide both sides by 5. And 5 is a positive number, so it's not going to change the inequality sign. If we divided both sides by a negative number, it would. So we would end up with n is greater than 24 fifths. And you don't need to reach for your calculator and say 4.8. It's absolutely fine to leave it as 24 fifths if you wish. Question 23. There are 60 students at a college and 20 students study both French and Spanish. So here is French and here is Spanish. So surely the 20 would have to be here, because that's the only situation where we're part of French and Spanish both. Now 13 students study French but not Spanish. So the 13 would have to go here, because in this part here, you are in French, but you're certainly not in the Spanish part. A total of 43 students study Spanish. Well, we know definitely that we've got 20 here already studying Spanish, although they study French. That's not important right now. It says 43 students study Spanish, so we've got 20 of them, so that's going to leave us with 23. So now we've got to look at this situation. One of the students at the college is to be selected at random. So the first thing that we should look at is to ensure that what we've written in our Venn diagram adds up to 60, and unfortunately it adds up to 56. So I know there's something missing here, and that should be 4. And that means you don't study French or Spanish or French and Spanish. Okay, so it's neither. And now we are ready to do the next part. Write down the probability that this student studies neither French nor Spanish. Well, that's not too bad then, because if you don't study French nor, not or, but nor Spanish, it means you'd be in this situation, which would mean that your probability would be, and I write it just here, it would be 4 out of the total, which is 60. And cancel that down. I don't think you'd have to. I think that would be fine, but you could cancel it to 2 out of 30 or 1 in 15. But I think 4 out of 60 gives you a little bit more of a feel for what's going on in the question. Question 24. This is number 2 on the higher paper, so there's a longer explanation on there. But I think for a foundation student, the quickest way of doing this question is, if I link one point here to a corresponding point here, join them up, the halfway point at right angles, i.e. the perpendicular bisector, or the right angle bisector, cuts it in half. On that green dotted line is where the centre of rotation will be. Now, a lot of students thought that it was this point here, and if you use your tracing paper, it will just not work. So we can test that out. Let's have a look if that works. And you can see it doesn't quite work. So there's P, and if we turn it around to Q, we can go clockwise or anti-clockwise. Doesn't work. But if we do it around the point 0, -1, can you see? There we go. It works. So there's Q, there's P, there's Q, there's P. Okay, so that should give you an idea of a quick way of doing it. And there's my explanation here. A clockwise rotation of 270 degrees about 0 -1, or an anti-clockwise rotation about 0 -1, and I should say 90 degrees. Jean records the maximum daily temperature each day for 10 days. She also records the number of children going to a paddling pool for each of these days. She draws this scatter graph for her information. Apparently Jean's information for one of these days is an outlier on the scatter graph. Well, I think we can find out that's the case here. And it seemed to say that although it was 24 degrees, not many children went out to the paddling pool. And what does it ask us to do? Well, it says give a possible reason for this. Well, a simple one could have been it could have rained that day. Another reason is perhaps, I'm not going to write this, perhaps that was a school day, for example, so people were at school. It then says, on the 11th day, the maximum daily temperature was 19 degrees centigrade. Write down an estimate for the number of children going to the paddling pool on the 11th day. Well, it's basically saying, use the information that you have and try and extrapolate from there. And when I say extrapolate, it just means using what you have before, make some prediction. Well, first of all, I'm going to draw my line of best fit, and then I'm going to look at 19 degrees. So let's move this down here. 19 degrees, you'd use your ruler obviously. Read along to your line, which is placed so it cuts, nicely between as many points. There's as many left as there is right. You can't get that exactly the same every time, but as long as it makes the eye look like the correlation should be, and then you can read along here and you can say, okay, 15, 16, 17, 18 students, okay? The next thing it asks for is, it says it would not be sensible to use a scatter graph to predict the number of children going to the paddling pool in a day when the maximum daily temperature was 13 degrees centigrade. Give a reason why. Now, let's have a look. So we can ignore my readings there, so take that to one side. And if we look at 13 degrees centigrade, well, I can't really extrapolate from there, because if I carried my line down here and tried to, I would more than like get a negative amount of children going to the paddling pool, which would not make any sense whatsoever. So I'd probably say both of those things. I would say, let's move this back. I would say the data is out of range. I would get a negative amount of children. And that's good enough. That's probably more than enough. Question 26. What we've got to do is work out the area of the shaded part. So the first thing I'm going to do is try and work out as many lengths as I can that I'm missing. So I know that I've got a 2 here and a 4 here. So this is going to be 6 meters. And then I know I've got this part here which is going to correspond to this 3 here. But then I don't know what this part is, and I don't know what this part is either. So I'm going to call that x. Now, luckily for us, the questions give us a clue. It says the perimeter of the shape is 28 meters. So if we start from somewhere here and go clockwise round, we'll have 3 plus 6 plus 3 plus x plus 4 plus x plus 2. So that's going all the way round back to the beginning again. And that's going to be equal to 28. So let's simplify. It's 2x, 3, 6, 12, 16, 18. We can halve everything. And just by looking you can see x is going to be 5 here, but you can take 9 from both sides and you'll get x equals 5 meters. So now it's going to be nice, because what I would do is I would now find the area of the whole shape by doing this. I'm going to enclose a rectangle around it. And I know that the area of the rectangle, the green rectangle, will be 6 by, well, don't forget this is 5, we know what that is. So 5 and 3 is 8, so that's 48. And then I'm going to take away this little part here, which would be 5 by, don't forget this part here was 2. So I've got to take away 10. So I've got to do 2 times 5, which is 10. Then I've got to do 48, take away that 10, because it was too much, wasn't it? So I had to take that little bit off. So that gives us 38 meter squares. And that's the area of the whole shape. But I want the shaded part. So I hope you can see this. I'm just going to quickly find the area of these 2 right angled triangles, take it away from 38, and that will be the shaded part left for me. So if I call this 1 and 2, so triangle 1, well that's going to be base. It doesn't matter which base we choose because they're at right angles. So I'm going to do 3 times 6 and then halve it, because it's base times height divided by 2, which is 18 over 2, which is 9 meter squares. And triangle 2, that's going to be base, which is 8 times height, and then halve that, and that's going to be 32 over 2, which is 16 meter squares. So if I add those 2 triangles up, 16 and the 9, that gives me 25 meter squares. So the shaded part, or shaded area let's say, is going to be now 38, let's change this, it's going to be 38 minus the 2 triangles added together, which gives us 13 meter squares for the shaded part. Now if you want to look at another explanation for this question, then you can look at how I did it for the higher paper, because this question appeared on both papers. Question 27, we have to solve the simultaneous equations 4x plus y equals 10 and x minus 5y equals 13. Well, if you have the time, I suggest you look into one of my playlists which is called Simultaneous Equations, and I definitely have videos on them, and they start off with some easy ones and get through to some difficult ones, so I would take your time to have a look at some of those, or other people's, that's fine, because my explanation is going to be reasonably good, but not much detail, not a massive amount anyway. So for this one here, we've got equation A and equation B, and I'm going to do this by elimination. So I think the first thing to look about is thinking about B, and if we times everything through by 4, left and right hand side, if we times the left hand side of that by 4, we'd get 4x minus 20y, and by 4 here we'd have 52, and I'll call that equation C. And if you notice here, the numbers in front of the x's are the same, i.e. the coefficients, i.e. the numbers in front of the x are the same. So I would just write these out separately here, just for explanation. So there was my equation A. Here's my equation C. And as I've times both sides by 4, I haven't changed any values here. It's still the same equation, just looks a little different. Now, I can now eliminate x, because if I do this step, and this is how I teach my students, I take one of the equations and I times both sides by -1. So just bear with me, I'll do this one, times this by -1, this by -1, and this by -1, and then I always add them together. And the nice thing is that I'll have 4x and minus 4x, which is no x at all. I'll have 1y and 20 more, which will give me 21y. And then here I'll have 10 and negative 52, which is negative 42. And hopefully then, if you divide both sides by 21, you can use your calculator, you will get y is -2. The nice thing about this is you can then go back to either A, B, C, whichever one you want. I would go into, personally, I think A, so I'd substitute into A, and I would have 4x and my y value, which was -2, equals 10. So that means 4x. Well, if you think about it, if you're adding a debt, you're creating a debt, so you're taking £2, or think of it as pounds, that always helps me anyway. Add 2 to both sides of this equation, and then I'd have 4x equals 12, so x would be 3. So there are plenty of ways of doing this, and like I said, do some revision on this and look at some other people's videos, and you'll learn quite a lot. Question 28. We've got to complete, first of all, the table of values for y equals 3 divided by x, or 3 over x. So you can have your calculator at the ready, and if x is a half, 3 divided by a half should give you 6. You can then check that if x is 1, then 3 divided by 1 would give 3, so that's fine. And if we did 3 divided by 2, that's 1.5. 3 divided by 3, that would give us 1. You can see these numbers are diminishing here. And if we do 3 divided by 5 on the calculator, you should get 0.6. And 3 divided by 6 is a half, or 0.5. So that bit's not too bad. Now on the grid, we've got to draw the graph of that function, y equals 3x, for values of x from 0.5 to 6. So let's have a look if we can do that. So we've got to be very careful that we plot things correctly. So if x is 0.5, then we've got 6. If x is 1, we've got 3. If x is 2, we've got 1.5. If x is 3, we've got 1. 4, 0.75. So be careful here. There would be a half, so 0.75 would be there. And then 5 would be 0.6. So careful of your scale. So each little tiny square is 0.1. So we want 0.6 would be here. And then 6 would be 0.5, which would be here. Now we want to draw the curve nice and smoothly. So what I would actually do if it was my piece of paper is I would turn this around here. So I was drawing from underneath, and I would draw the arc from underneath. So I would do like so, and then turn my page a little more, and then carry on from there to here. That's not brilliant, so I'll probably with my pencil rub that out, and then I'll go from here to there, which is not brilliant, but it will do for the exam. And then I'll turn my page back. What I wouldn't do is start from here, and I'll do this in another colour. I'll probably do this even better now I've done that. I would certainly not have my pen from underneath and start doing that, because that's just going to be a bit crooked. It's much easier for me to turn my page when I'm doing that. So take that advice or don't, it's up to you. Question 29. Samir invests £350 in a savings account. He gets 2% per annum, per year, compound interest. Now, what that means is that we have the £350, which is called the principal amount, and we want to apply 2% interest to it. So what we end up with at the end of the first year is not just the 2% of interest, but what is left in the account at the end. So if we were to times 350 by 1, we would just get the amount at the end of the year with no interest at all. So what do you think we would times by to add 2% on? Well, if you times by 1.5 or 1.50, that's the same as doing 350 times 1 plus 0.5. And you should know, and you can use your calculator for this if you want, that if you times 350 by the 1, you'd get 350. And then if you did 350 by a half, that's half of 350, which is 175. So that would have the effect of adding 50% to the original amount. We only want to add 2% to it. So what you would do, you'd have to do 350 times 1.02. And if you do that on your calculator, you'd have 350 times 1.02. And that would give you exactly what is in the account at the end of year 1. So then, to get the compound interest, you do the same process to the amount you have at the end of year 1, and you keep doing that cycle. So for the end of year 2, you'd have to apply the same interest rate again, so you just times by 1.02, and on my calculator I get 364.14, so that's £364.14, that's at the end of year 2, so I'll put end here. And then, I think you probably work this out, you then do £364.14 and apply the 1.02 again to it. That's called the multiplier, by the way. And so we'll times that by 1.02 and we'll have £371, and then it looks like 0.4228 of a pound. Let's not worry about that just now. When we come to give our answer, we would write £371.42 because we'd round it to the nearest penny because the unit is pounds. There is a quicker way, and some of you may know this, and if you do, you probably skip this question anyway, and you would times it by 1.02, that was what was in at the end of year 1, and then we did this again, didn't we? And then we did this again. Now all of those brackets are not really necessary, and the reason is because we're under the operation of multiplication. Now there's quite a lot of theory about that, in terms of pure maths, but in short, it's the same as writing this. And some of you have already seen that that is the same as writing this. So if you have a principal amount and you want to times it by an interest rate of 2% for a number of years, that's exactly what you do, and that would be a really short way of doing it on your calculator. So if you tried this on your calculator all in one go and rounded it, this is what you would get.